Homework 13, section 7.1, the standard normal curve, video 5. In the previous video, we talked about what a normal curve was and what a standard normal curve was. Basically, they're both bell curves, but what makes a standard normal curve standard is that the mean is 0 and the standard deviation is 1. And we also discovered that in a standard normal distribution, the numbers on the number line on the bottom are actually z-scores. That's going to be very, very important. So, how are we going to find these areas underneath the curves that represent the probability of being between two values or greater than one value or less than one value? And the answer is we're going to use what's called a standard normal distribution table, or more succinctly, a z-table. Now, this table is available in Canvas. If you look at an announcement, you'll notice that there's a link to this table. In a minute, I'm going to take my phone and show you what it looks like on my laptop when the time is right. But let's see what the types of problems are going to look like. For example, find the area under a standard normal curve, so a bell curve centered at 0 with a standard deviation of 1, to the left of z equals negative 2.28. Now, before we get this answer, it's important to point out that there are two things you need to think every time you see a question about a bell curve, about a standard normal curve. Number one, every area represents a probability. In this case, we're looking at the area to the left of a z value. Well, on a number line, when you go to the left, you're looking at values that are less than something. So to the left of z equals negative 2.28 means that we're looking at the probability that z is less than or equal to negative 2.28. And again, whether or not we use the equal sign underneath is irrelevant in terms of the calculations. Later, when we look at word problems, the context may dictate whether or not we want this to be able to be equal or not. But for now, it's irrelevant. So the area we're looking for is going to represent the probability that z is less than or equal to negative 2.28. And this might be easier to see if we draw an illustration. Every probability involving z, or involving a normal curve, not just a standard normal curve, has a picture associated with it. To draw the picture, you always start by drawing a bell curve. And then in the middle, putting whatever the mean is for the distribution. Now, since we're in a standard normal curve, that means by definition the mean is 0. Then, locate the z value that you're looking around. In this case, z equals negative 2.28 would be to the left of 0 somewhere. It doesn't really matter where you put it as long as it's on the correct side of 0. To find the area to the left of this, draw a vertical line straight up from negative 2.28 and shade in the left area. So we want to know what this area is, and when we find that area, it's also going to be the answer to this probability problem. So you can see that these problems can be posed in three ways: descriptively, visually, and theoretically as a probability question. So, if we can find this area, then we're good to go. Now, how do we find the area? We use a z-table. Now, I forgot to put this in the top of the z-table. Actually, I might have put it in there. We'll find out in a moment. But the important thing to remember about the z-table is it tells you left areas. Before we fill this in, I'm going to grab my phone and show you the z-table, the standard normal distribution table that is linked in an announcement in Canvas. I've got it right here next to my phone. You can't see it yet. Alrighty. Not perfectly lined up, but I don't want to mess with the legs on my tripod. Okay, so if you print this in black and white, then maybe the yellow parts will be shaded. The only reason they're yellow is to make it easier to read across a given row. The way the Z table is set up, and it does say area to the left of a Z-score, so I did remember to put that in the title. The way a Z chart works, or a Z table, is your Z value is split into two parts. The number to the left of the decimal and the number to the right of the decimal is in the left column, and on the top is the second decimal place. So 0, 1, 2, 3, 4, 5, 6, 7, or 8. So for example, going back to our problem, I just messed up the tripod legs. We're looking at sorry, that messed up the focus. We're looking at negative 2.28. So when you are looking up a Z-score in the Z chart, you need to look at this Z value as two parts. One part is the numbers on either side of the decimal, and the other part is the second decimal place. So we're going to go down the first column and locate negative 2.2. Then we're going to go across to the column with 8 in it, 0.08. And then where that column and that row intersect will be a number. That number will represent the area to the left of negative 2.28, and that will be the answer to our question. So let's go back and look at the table. Let it focus. Okay, so to find the area to the left of negative 2.28, start by looking for negative 2.2 in the left column. It's way down here in this bottom yellow row. Then go all the way across until you get to the column that represents the 8 in the second decimal place. So we're going to go down this column, across this row, and the intersection is right here. That's my birthday. That was a complete coincidence. 0.0113, where my dirty fingernail is kind of hovering over right now. It's going to be crucial to know how to use this chart. In fact, it's the lifeblood for the next few homework sections. So again, this tells you area to the left of a Z-score under a standard normal distribution. To find the area, the two numbers on either side of the decimal place are in the leftmost column, so negative 2.2. The next decimal place is on the top, 8. See where the column and the row intersect, and that value represents the area to the left of that Z-score. So 0.0113 is the answer to every question on the board. Give me 1 second to get this refocused. There we go. I promise I didn't pick this one because it was my birthday, January 13th. I picked it because I wanted to go as far down the chart as I could without having to scroll. So in the Z chart, in the negative 2.2 row in the 0.08 column is the number 0.0113. That represents the area to the left of that Z-score. So the answers to all these questions, excuse me, that was supposed to say answer. That area is 0.0113, which is also the answer to the question, even though it wasn't asked. The probability of Z being less than or equal to negative 2.28 is 0.013. Excuse me, 0.0113. And what it also means is if we have continuous data that is normally distributed with a mean of 0 and a standard deviation of 1, we can expect 1.13% of those values to be less than negative 2.28. We're going to do a few more area problems using a standard normal curve, a Z-table, because after all, our Z-table only tells you the area to the left of something. What if we want to know the area to the right of something? Or what if we want to know the area between two values? Or what if we know an area and we want to know the Z that cuts that area off? We're going to answer all of those questions in a moment.